So after learning how to be a better programmer and learning about data structures and processors, um, writing code is more complicated than it seems, uh, especially if you're going for efficiency. So here we can see how uh, this function needed 8 gigabytes of RAM probably, and then this one needed 500 megabytes, and then this one needed 56. So this one needed the least, but it also took 3 minutes and some to run, whereas this one took a minute and a half, and then this one took just a second. And they all gave the same result, as you can see here. So you know, there's some trade-offs between computation speed and then memory limits. So writing better code needs some kind of understanding of this. This will all just run again on its own. And you don't need to, if it's something that needs to be redone and redone, some recursive function, then shifting from this to this, or from this to this, might be useful. So here we can see how there's different files and some options that are given for this function. This is the built-in function that gives the dimensions, gives these dimensions, and then it requires this amount of memory to perform the computation. This all uses the same amount of memory pretty much. So, you know, that's telling. And then this uses much less. What is that, not even a megabyte? Yeah, that's half a megabyte. Whereas this uses 3 gigabytes, right? So, and then this shows that their results are the same. This is another file that's much simpler, 21 by 4, and then for this kind of simpler data, the functions are pretty much the same. Yeah, and then here you can see that the results are also the same. This just requires some refinements, right? This, actually just specifically this, is what this one should be, maybe, to expression. Or maybe another one, depending on the use case. There's another file that uses the same specifications as this one. And then this one is a bit heavier file, almost 1,000,000 by 50, and these all use the same amount of memory, right? Even this, you know, more specific specification doesn't give the same. And then this one is both faster and uses less memory. And it's because this one is using a more lower level approach. It involves, similarly to this, in the way that this is the fastest, but then it uses some amount of memory just due to what it's storing, right? So this custom function implements this function and then data structures, and in order to optimize for speed to some extent, and then for memory capacities. So sometimes it's not the fastest. This one is faster. Um, let's see this one. Let's see how long this takes. Echo timing, and then we need to respecify this. This one might take some time. As you can see, this one took 3 minutes. Huh. And then for this one, it would also be nice to know how long the simpler one takes. Just import the file dimensions. Right. Echo timing, then max memory used. Let's see. It is doing this one. Oh, that's pretty quick. Oh, is that a different file? Oh no, it's not. It's not. It's just the memory usage. The fact that this uses 8 gigabytes is somewhat astounding. Yeah. So you need to have a clear understanding of the lower level stuff to be able to write the higher level stuff more effectively. There is some middle way involved. But then once all the functions are just written well for their specific use case, as other code systems, it just runs like magic, and you can do specific optimizations like this, in which it's both quicker and then more memory efficient. So if it's faster and better, then that's great, and that's what a lot of the code writing involves. Yep.